Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video, I want to share about the problem in the Success Phase 2 second semester Physics grade 11. Okay, so number 1. Answer the following question. Closed pipe produces the third harmonic, the active one of A note. The speed of sound in organ pipe is 330 meters per second. Calculate the length of the organ pipe. Yeah. The key in this question is the octave one A note. Yeah, we can find the frequency of the octave one of A note. This one, this is a frequency 55. Frequency is 55 hertz, and then the speed is 330 meters per second. Calculate, and the N is the third harmonic. Yeah, see, third harmonic. So for the question A, calculate the length. F is N per, because it's the close, N per 4, V per L. Okay, and the 3 per 4, V 330 per L. You can to change L with the F. L is 330 for okay, 1 6 2 3 9 per 2 4.5 meter. Okay, it's the answer number E. And the P, explain what must be done to close and pipe produce an octave. Okay, if the frequency is the A active 5, you can find the octave 5. Yeah, this frequency is the same as the third harmonic. 2 per, sorry, 3 per 4, V per L. Is the same with the A, because it's a different number for the frequency. Okay, number 3, A, 9 per 32 meter. So you can answer is the what must be done to the close organ pipe is you can make the pipe is shorter, better. The pipe is short. Okay. Number 2, an open organ pipe A and a closed organ pipe B have the same length. Expand the ratio of the second harmonic organ by A and the third harmonic organ by B. Yeah. The K is the first is the same length. Okay. LA is the same LB. Expand the ratio of the second harmonic. Second harmonic is the A is 2, and the third harmonic organ B and B is 3. Yeah. And the pipe A is the open organ and the pipe B is closed organ. So ratio, yeah, and the FA with the FB, the open organ N per 2 P per L, but then FB close N per 4 P L. If the V is the same and the L is the same too, so you can sub the N with the 2 per 2, then for the B is the N is the 3 per 4. Yeah. Okay. We can cross with the because in the bottom for the B is the 4, we can cross with the 4, and the left in the 4 too. Yeah, 3. Okay, 4. Yeah, the ratio frequency A, then frequency of the pipe B is the 4 and 3. Number 3, the frequency of the third harmonic open the purple is the same frequency and the first harmonic close open here. Okay. Is the same frequency. Fx is the same Fy. Yeah. Fx is the third harmonic. Yeah, is the open. The N is 3, and the pipe B, pipe Y is the fourth harmonic. The N is 1, is the close. Okay, and the length of the pipe X is 50. Okay, for Fx, because this the open organ N per 2 V per L, and the for pipe of Y is the close N per 4 V per L. The V is the same. Okay, and this one the length of the pipe X is the 50 centimeter. So 3 per 2, 1 per 50, and then for the Y is the first, the half, 1 for yeah, 3 for 100, 1 for 4L. You can cross 3 and 100. L is 100 per 12. Okay, 25 per 3 centimeter. Okay, this is A. And the B. Explain the ratio of the fifth harmonic pipe X and pipe Y. Okay, F X, this ratio, the difference of the A, if the same frequency. The fifth harmonic, okay, the same. N per 2 P per L, N per 2 P per L. Okay, the fifth because the n is the same, so you can do clear for n. Phi is the same too. Okay, 1 per 2 50 centimeter. 1, oh sorry, it's the 4. 4, okay, 3. And then we can do change the 4 cross 3 per 25. 1, 3 per 100. Yeah, 1, sorry, 3. This is the ratio. Okay, correct. Number 4. An organ pipe forms wave as shown in the following image. The L, the length is the 80 centimeter, and this open, yes, open organ. How about the N? And 1, number 1, number 2. So the N is second. Okay, if the speed of the sound is 340 meters per second, calculate the frequency. Okay, because this open organ, N per 2 P per N. This N2 per 2 P 340. The N is 80 centimeter. Yeah, we can to change the unit of length for 80 plus 2. 1. Okay. Eight, 3, eight, okay. 4. Okay, the result is 425 hertz. Okay, and the B. Name the 3 musical instruments that use this type. Is I think you can find this in the module. Yeah, the name 3 musical instruments that use this type of pipe. This type is open organ. Okay, this is the key. Number 5. An organ pipe is a musical instrument that produces sound by resonant pressure air went through a tube. When air diffused through an organ, it is prepared and produces a sound. Expand with the picture. Okay. The wave from the fifth harmonic in open organ. Fifth. Okay. The first is the open organ. Okay, open is the only open. 1, 2, 3, 4, 5. I'm sorry. Yeah, it's the open. And the close. You remember, for the close, for it's not the 1, 2, 3, but it's 1, 3, 5. Yeah, 1. Okay, 3, 5. Okay, this close or again, yeah, 1 3 5, but for the open is 1 2 3 4 5 6 units. And the B, explain the difference between pressure and displacement at the open end and closed end. Yeah, for open, yeah, I think you can see in the answer of E, the open, the displacement is maximum. Yeah, you can see for open, yeah, for open is the open end is the maximum, but for the pressure is 0, or okay. And then for close end, yeah, close end, for example in the second, yeah, the close end, the displacement is 0 and the pressure is maximum. Yeah, okay. Number 6, read the text extract, answer the question that follows. Yeah, it is the story about the diffraction. Okay, you can see the following data will record. Yeah. In investigation to determine the wavelength of light from laser, the light passes through the diffraction grating with the 200 lens per millimeter. A diffraction pattern consists of the cells appears just what the observer on the screen. The following data will record distance between the grid. Yeah. This is the N, and the distance between grating screen. Yeah. This is the L. Okay. Distance from maximum to second order. Yeah. This is the M. This one is the Y. Calculate the wavelength. You can remember the formula. Yeah. T Y per L is the same M with lambda. Yeah. What's the T? Yeah. Before you sub the data in the formula, you can change the units. Yeah, you can change units. I think for you is easy. So the units all you can change to the nanometer. Nanometer. Yeah. For example, T is the T. This is with per N, W per L, M lambda. Okay. This one sub 1 per 20 lens millimeter. So you can millimeter to millimeter to nanometer is taken 1 6, yeah, 4 meter to nanometer 9 centimeter to nanometer is 7. Okay. For millimeter is 6, and Y is the 60. Sorry, 7 and the L3 to 9. The M is 2, the lambda. Okay. $60, 10 to 30, and then lambda. Okay, for this one. Okay, lambda is okay, so lambda is 500 nanometer. Okay, and the B, calculate the distance from the central maximum to third order maximum. Okay, yeah, with the same formula you can find D EY per L M lambda. You can sub the lambda to the formula. Yeah. Okay, the Y is the answer. The same. The third order, so the M is 3. Okay. Y. Okay. Y association with the Y. Okay. One, two, three, 4. Okay. 8. 1, 2, 3, 4, 5. 5 plus 3 is 8. 8 nanometer or centimeter. The weight is 90 centimeter. Number 7. Like from a laser point with space towards the diffracting grating, like was perpendicular. Yeah. If the T, yeah, distance from the grating to screen. Yeah. And the measure to be the lambda one is this one with the Y is Y. Sorry, it's Y and this one is lambda. The parameters replaced with the second laser different wavelength. The new distance X is calculate the diffraction grating. Yeah. Okay. For the problem, is super n y per n, because this the first order, the m is 1. Yeah. And the y is half meter. Yeah, half meter. So you can change the way to nanometer. I think it's the same. It's 9, then 50, 92. The m is 1, and the lambda is 400. I think it's the same. Super n is the one. Yeah, so correspond to 5, and is nanometer. You can change for nanometer to millimeter. Nanometer is the, I think, 6 here. Two, 3. The n is 1 per 2, 3. I tend to move the 10. 3 per 2, 100 per 2. So the n is per millimeter. This is the n. 500 per millimeter. Okay. And the B, calculate the wavelength going to. I think for the formula, super n is the same. Super n is the same, and then for the y, l is the same. You can find the formula per n y per n m lambda. So you can find the super n is m lambda l per y. I think it's the same in the first lesson and the second lesson. So m lambda l per y, the first, and the second lesson, and 2 L2 per y2. The m is the same, and the l is the same too. So you can do ratio. Lambda 1 is 400. 1 per y1 is the half meter, and the lambda 2 is I define with it, and the y2 is okay. So the lambda move to 0.5 is 400. Okay. Yeah. Five is to 24 18 nano. Yeah, this one. Okay, let's see. Explain two things to get the first order distance from the sum is smaller. Explain. Is the first order from the sum is smaller. Expand to you can the first I think sorry it's big P, yeah. For the C, what do you think? The first order distance from the center is the smaller. If you can the first, yeah, the first you can to the distance creating and screen smaller, yeah. And the second you can change, yeah, you can change the diffraction creating is smaller of 100 per millimeter, yeah. No, sorry, not 200, 500. Yeah, you can the change the diffraction creating is smaller too, and the distance creating to screen is the smaller. Yeah, I think to explain two things. You can to is two. Yeah, the first is distance creating and screen smaller. The second, you can to change the diffraction creating is smaller too. Yeah, the first is 500 per millimeter. Yeah, you can change the creating is the smaller of 500 per millimeter. Okay, and number 8, the arrangement shown that was used to determine the wavelength of the light emitted by laser. Yeah. The sin of theta. The diffraction grating is 200 lens per millimeter. Determine the wavelength. Okay. Okay. For the A, yeah, for N is a sin theta m lambda per 200. You can to change the nanometer, yeah, cross 10 5. Okay, sin if you want to the first, so the n1, sorry, it's m1, yeah, m, yeah, not m. Well, m is 1 lambda. Okay, so lambda no 0 to 6 per 2. 1 2 3 1 2 3. One, two, one, per 2 lambda. Lambda is 410 nanometer. Okay, this is the color of the emitted from the laser. Okay, B, you can find the lambda is 410 nanometer. You can find in the data in the first page, yeah, 410. You can use this one. So the color is violet. Yeah, the color is violet. Okay. Okay. Next, the number 9. Okay. The X is the first order, and the N, the X, you can change the unit to nanometer, change the 7 nanometer, and this one, yeah, 9 nanometer. Okay, kalau kedua, I think this is the first order. So the M is 1. M is 1. So per N, Y per L, M lambda. This one millimeter, yeah, cross with the 6. The Y is 7, 2.59. M, sorry, the M is 1 lambda. Yeah, okay, I think you cross. Okay. This one and this one, 13. You can use 500. Yeah, and 10, 13. That is 100 nanometer. Okay, so the student replace the difference in pacing with the number of line. Calculate the distance first order. Pacing with the same lambda, then you can change the per n. Yeah. And calculate the distance of first order. I think y can fire and l is the same. M nya is the 1, the lambda is 0. Oh sorry, 1000. Yeah. You can move the bottom to the right side. Y 100 plus with 200 to 1000 to 200. Oh, not just 30 or 300, sorry. One, two, three, four, 5. 1, 2, 3, 4, 5. 5 plus 14. Y is Okay, the y is 7. Yeah, sorry, x. Y is 3. This is 1. This is a nanometer. We can change, yeah. Sorry, we can move this one in the arm. Nanometer. You can change this unit to centimeter. Okay, 7, 1. Yeah, 75 centimeter. Yeah, if the creating the higher from before, and the y of the distance, the distance first order is I think is the height. Yeah, before is 50 to 75 centimeter. Okay, the last number, the diffraction of the light provided happens that way. Okay, you can see the creating lens, the N 100, and observe the diffraction pattern the screen, the L. Yeah, the student measure the distance, the Y. Okay, why we reduce the color? I think you can find the lambda wavelength, and Y per L M lambda. Yeah, the creating is 30 millimeter. You can cross with the N and the Y. The Y is 30 centimeter, change to nanometer 7, and the L is 2 meter for the millimeter, change is the third order, so the M is 3. Okay, further up 30, cross with the 13, and the bottom 200, and 300. Okay, 4, 3, 4 per. So lambda is 3 for 20. So lambda is 4 20. 1000 per 2 is sorry, nanometer. The color 500. You can find this data. 500 is this one. No, is this. So the color is green. The color is green. Okay. Calculate the distance of the central maximum. The first, you can find thing with same with this, but the M is 1. You can find the Y. Sorry, 100. 6 is the Y. The L is the same. 2 9 1 the pattern. Yeah, you can move in the bottom to the right side. Y 100 is 500 plus the 100 2.09 y 1 5 plus 1 plus 2 is 10 cross 1 2 3 4 4 plus 9 is 13 4 okay 10 cross 7 nano with the chain with the millimeter, yeah, so 10 centimeter. Okay, this is number B. Okay, thank you. Is the all, for the all solution for the problem in the success PAS second semester. Thank you very much and see you in the next semester. Wassalamualaikum warahmatullahi wabarakatuh.